There's a lot to consider when you're designing mirrors for a space telescope. They need to be lightweight, sturdy, and not change shape so much just because it's a little cold, like 400 degrees below zero. Glass won't do the trick like it does here on Earth, but beryllium will. So where do you find this rare metal? The West Desert of Utah, of course. Hey, so Rob, where are we going?
We're headed to our current active open pit beryllium mine. This mine is the only mine like this in the entire world. So these are the only beryllium miners that you'll find. We are currently standing on the edge of our active pit where the hard rock is being excavated that covers the beryllium ore.
So why is beryllium so valuable?
It is very strong and very light. It's a third the weight of aluminum and has 6 times the stiffness of steel.
How tough is it to find beryllium?
It took us about 30 years to gather all the data and information to design and develop this mine.
And once the ore leaves this mine, is it ready for the folks at the James Webb Space Telescope program to use it to build the mirrors?
No, after the ore material leaves the mine, it is shipped to the processing plant about 50 miles east of here.
Oh, great. Well, thank you so much for welcoming us and letting us see your beryllium mine.
You're very welcome.
So, Phil, we just came from the beryllium mine, and Rob told us that you guys take the ore that they over there dig up.
Yes, that's right. The ore is hauled in and put up in these pockets here, and then we crush that ore and mix it with water to start the process.
All right, so Phil, we just came from the ore, and you said they crush it, and then what?
Well, this is the ore, what we get from the mine, and then we crush it to a very fine slurry, and then after we leach it, we have the beryllium in the water, and the bottom has most of the beryllium leached out of it. What's happening here is that the slurry from the leaching area is brought out here through a pipeline, and it goes into this well where it's mixed with a flocculant.
What's a flocculant?
It ties up the fine particles with the big particles so they will settle to the bottom.
Okay.
And then the clear overflow becomes the solution that we process to get the beryllium out of. This is a solution that we just came from those big tanks out there, and that'll be filtered to remove those fine particles. And then we mix that solution with the organic layer, and the beryllium goes into the organic layer, and most of the impurities stay in the water layer.
Now, you said organic layer. What does that mean to the rest of us?
It's like oil and vinegar. This is the oil in your oil and vinegar.
So you're putting oil in, or you're putting vinegar in?
Yes.
Both.
Both.
Okay.
The vinegar would be the water solution, and we have a special extractant in the oil layer.
Okay.
So it flows to the top, and we can concentrate and purify the beryllium.
It's still a liquid here. What then happens?
We purify it and precipitate it into a powder, which we then package.
Beryllium dust is not exactly the best thing to be near, but can we see something that resembles a powder?
Yes, I have some sodium carbonate right here, which is very similar to the texture and the fluffiness of our powder if it was dry.
It looks kind of like a talcum powder, really.
But very much so.
Okay.
These are the drums that we have our material in, ready for shipment.
And you said shipment. Where are they going to go to next?
These will probably go to Elmore, Ohio.
Elmore, Ohio has what?
Elmore, Ohio is the plant Brusher Ullman owns that converts it into finished goods.
So it's going to come out looking like a metal.
Yes, it'll come out as a metal, an alloy, or an oxide.
Well, thanks so much for showing us your plant.
You're certainly welcome.
While you can find beryllium mixed with metals in everyday life, like computers, cell phones, and even your car, you can only find pure beryllium in specialized items like X-ray machines, space satellites, and now the James Webb Space Telescope. Thanks for joining us for this edition of Behind the Web.